Hello students, welcome to the physics of class 12th. We are studying electrostatic and this is my video lecture number 9B. Look here, try to pay the attention. I am giving a number on this place and you have to look the all videos in the serial of this number. My dear students, today I will teach you about the intensity of electric field due to point charge. Yes, my dear students, look here. Today I will teach you intensity of electric field due to point charge. My dear students, if I will talk about the intensity of electric field, then I want to remind you, you have already read about the intensity of electric field. I have already taught about the intensity of electric field to you in my previous video lecture. My dear students, look here. Here I am taking a uniform electric field. Look here, very important topic of the physics. Intensity of electric field, it means, my dear student, strength of electric field. If I will take the several point in the electric field, then the strength of electric field will be different on several point. Yes, my dear students, here strength will be different compared to this place and here strength will be different compared to this place. How we can recognize, how we can identify what is the strength of electric field on this place, that is intensity of electric field. Yes, my dear students, intensity of electric field. How we can measure the intensity of electric field? If I want to measure the intensity of electric field, my dear students, and on any point, then I will put a test charge on that point, and you know test charge will experience the force that I will make the numerator and the magnitude of the test charge I will make the denominator. Thus we will get the intensity of electric field, my dear students. In previous video lecture, I discussed about the intensity of electric field. Look here, what is formula due to which we can find the intensity of electric field, my dear students? E vector is equal to F vector upon Q naught. Intensity of electric field is a vector physical quantity. So we have to put the arrow on the top of the E. My dear students, little bit a different topic I am going to teach you. Intensity of electric field due to point charge. If a point charge is present here, or you can say a isolated point charge is present here, its nature is positive. Any types of nature we can take. Later we will take the nature of source charge is negative. Look here. My dear students, here I am taking a source charge plus Q, and you know if charge is stationary at one place or charges are stationary at one place, then charges will develop, charges will create, charges will produce, charges will generate electric field, my dear students. And that electric field we can't look, we can't see, we can't view, but we can draw with the help of test charge. Yes, my dear students, this is electric field of a positive nature charge plus Q. My dear students, if this is a electric field, then in the electric field, if I will take the several points, the intensity of the electric field will be different on each point. Can we relate this intensity to the source charge? Any relation of the intensity of electric field and source charge is present? Yes, my dear students, look here. If I will pick the source charge on this place and put on this place, and I will take a point A. Here I want to find the intensity of electric field, and my dear student, A is situated at the r distance from the source charge. If I want to find the intensity of electric field on the point A, then my dear students, here I will put a test charge, and test charge will experience the force according to the Coulomb's law, Q naught upon R square. Yes, my dear students, this is the magnitude of the force, this is the value of the force due to test charge. My dear students, look here, this is the value of force which a test charge will experience. We know the nature of test charge is positive, so source charge and test charge both will repel to each other. But here our target is different. We want to find the intensity of electric field on the point A. My dear students, here I will write E vector is equal to F vector upon Q naught. Thus we can find the formula due to which anyone can find the intensity of electric field due to point charge. My dear students, look here. E vector is equal to 1 upon 4 pi epsilon naught Q upon R square. This formula is present in scalar form. My dear students, if you want to write this formula in the vector form, then you can write E vector is equal to 1 upon 4 pi epsilon naught Q upon R square R cap, where R cap is a unit vector which direction is present from the source charge towards the test charge, my dear students. Dear students, you have to remember intensity of electric field is not a scalar physical quantity. Yes, my dear students, intensity of electric field is a vector physical quantity. A very big question is arising in this place. What is the direction of the intensity of electric field on any point? Look here. I am going to explain the direction of the intensity of electric field. My dear students, if I will put the test charge on this place, here source charge is positive. Nature of source charge is positive, and we want to find the intensity of electric field on the point A. For this purpose, I am putting a test charge on this place. If I will put the test charge on the point A, then test charge will take the repulsion due to source charge. And we know what is the magnitude of the force due to Coulomb's law. With the help of this formula, I can find, you can find, anyone can find the value of force which is acting between the source charge and test charge. My dear students, but here question is different. What is the direction of the intensity of electric field? And we know if we find the magnitude of the intensity of electric field, then here I will make this formula like this way, and the value of magnitude of the intensity of electric field is this. Look here, come on the topic, my dear students. What is the direction of the intensity of electric field on this point? Look here. Listen carefully, my dear students. The direction of intensity will present in the same direction where test charge will experience the force. Yes, my dear students, if I will make this point as O, and here I have already written this point is A, then look here, if the nature of source charge is positive and the nature of test charge is positive, then source charge and test charge both will repel to each other, and source charge is moving away from the test charge. So this is the direction of force, my dear student, O to A, and direction of force, my dear students, and it is also direction of intensity, means intensity will present in this direction because source charge will move towards this direction. Look here, this is the magnitude of the force, and by this way we can find the direction of the intensity of electric field, my dear students. Look here one time again. Look here, very important. If the nature of source charge is negative and we want to find the intensity of electric field on point A, then you know the magnitude of the intensity of electric field will be same, my dear students. But if I will put a test charge on this place, then test charge will experience the force in this direction. Source charge and test charge both will attract to each other, and this is the direction of force. So this is the direction of intensity of electric field. Yes, my dear students, I hope you are getting me, and you know how we can define, how we can find, how we can recognize the direction of intensity of electric field. Yes, my dear students, remember these things. Where test charge will move, that will be direction of intensity of electric field. One more topic I am going to teach you, my dear students, in the criteria of intensity of electric field due to point charge. Suppose this is a system and this system contains the number of n interacting charges, and we want to find the intensity of electric field on this point. My dear students, intensity of electric field is a vector physical quantity. So if I will put a test charge on this place, then test charge will experience the force. But look here, what is the magnitude of the intensity of electric field on this place? E vector is equal to E1 vector plus E2 vector plus E3 vector plus En vector. My dear students, if a system contains a number of n interacting charges, yes, my dear students, if a system contains the number of n interacting charges, then intensity of electric field on any point in the system will be vector sum of the intensities produced, created by the each charge on this place. Yes, my dear students, it means individual intensity will be not affected due to presence of all charges. Thus, our topic is completed. Thank you.